Hello everyone, myself is Devashish Roy. I'm the head of training and development at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is a very interesting one, and it is very important. That is First Hop Redundancy Protocols. We'll be talking about the HSRP, Hot Standby Router Protocol, VRRP, Virtual Router Redundancy Protocols, and GLBP, Gateway Load Balancing Protocols. So, what is redundancy? Why do you need the redundancy? And what is the difference between these two protocols and how to configure these, especially HSRP and GLBP? We will discuss in depth. So let's begin. So we will discuss in depth about the three protocols, VRRP, HSRP, and GLBP. But first of all, let's understand what is redundancy. Redundancy means you are having, say, only one connection. So that is not redundancy. It is single point of failure. For example, let's say you are connected to the ISP with the single link. So that is the one connection you're having. And let's say you are having multiple connections, two or more connections to the ISP or to multiple ISPs. In that case, yes, definitely you have the redundancy. So one link fails, another link will be up. So that is the redundancy. But if you are having only one link, then if that fails, everything is gone. So what is the first hop redundancy protocol? First Hop Redundancy Protocol, or FHRP, ensures high availability and reliability in network environments by enabling multiple routers to collaborate. So there are multiple routers, router 1, router 2, router 3, say 8 routers or 9 routers there, and you can have different links, different redundant links to the source. This collaboration presents a single virtual gateway to end devices. This is a big thing. Single virtual gateway means your virtual gateway or the default gateway is a single one because it is represented by one virtual IP address that we'll configure later. Now, what is VRRP? Virtual Router Redundancy Protocol enables automatic assignment of multiple IP routers to serve as a single virtual router for host your network. Yes, means there is a component that is virtual router. It is not the physical router. It is a virtual router that is included within the VRRP, HSRP, GLBP, these protocols. And they serve as a virtual router protocol. Means you can ping the address, you can ping the virtual IP address, but that is not physical. That is having virtual IP and virtual MAC as well. This protocol ensures continuous availability by allowing a backup router to seamlessly take over if the primary router fails. So it is a failover. Now, how VRRP works? First of all, shared virtual IP address. VRRP establishes a virtual IP address that multiple routers can share. So if you're having an IP, say for example 10.0.0.100, so that is shared among all the clients, all the other routers. They can ping the IP as well. And this enhances network reliability by providing a failover mechanism. Now, this virtual IP allows devices to send traffic without needing to know the specific active router. So, there is a component that is active router in the HSRP, and there is another component that is known as the standby router. So, who is the active? Who is the standby? That is not known to other routers, and how it is elected, that is also not known, but we can redirect the traffic to the single shared IP. Then the master and backup roles. In VRRP, one router is designated as a master router responsible for managing traffic through the virtual IP. Then the master router is elected based on priority setting. Yes, HSRP, VRRP, GLBP, all these are elected according to the priority basis. So every router, say, has a priority, a default priority. Now, if you change the priority, then say you are increasing the priority. If you increase the priority, then that becomes the active router. Now, active router concept is there in the HSRP, GLBP, VRRP, all three protocols, but active and standby concept is there in the HSRP, but in GLBP and other protocols, you have the active concept. Now, the master router is elected based on priority settings. ensures that the most capable router handles the primary traffic. Now, traffic handling by master router. How does master router handle traffic? The master router processes all incoming traffic directed to the virtual IP address. The setup allows for seamless communication with end devices. Means master router or active router, master means the active router, it takes all the traffic. And the standby router, it is idle. That is the problem in case of the VRRP or HSRP, as they're unaware of any changes in the physical router handling their traffic. Now, automatic failover mechanism. In the event that the master router say it has failed, so what will happen? The VRRP automatically promotes one of the backup routers to take over the master route. So the standby routers who are idle, they will become one of them, not all, but one of them will become the master or the active router based on the priority, the highest priority, and ensures continuous availability and minimizing the downtime. So what are the benefits of VRRP? Enhanced network reliability, automatic failover process, simplified network management, and minimized downtime impact. So these are the benefits. Now let's come to HSRP. So these protocols are almost similar, but VRRP is a bit old one. Nowadays we use mainly the HSRP and in some cases GLBP. So HSRP or Hot Standby Router Protocol is a proprietary protocol designed by Cisco system to enhance network reliability and availability. And this allows multiple routers to actually share and collaborate a single virtual IP address of the active router. So there are other routers. There you have configured the virtual IP address, one single virtual IP address that you can ping. Now, how HSRP works? It uses a shared virtual IP address that I have already told you. HSRP establishes a shared virtual IP address that multiple routers can access, forming a cohesive unit for routing traffic. And second is active and standby rules. Active and standby rules means that during operation, one router is designated as active router, which is responsible for processing and forwarding all traffic directed to the virtual IP. So you have one virtual router, and do not think that virtual router is a physical router. It is not like that. It is only a virtual device. It is an imagination, you can say. Now, failover mechanism. The active router continuously sends HSRP hello messages to maintain its status. So if I'm the active router, I will send hello messages to every other router. If it fails to respond, then the standby router assumes the active role to ensure uninterrupted services. Then seamless transition. In the event of a failure, the standby router quickly takes over the active role and minimizes downtime and ensures that continuity of service is happening there. So it is an automatic failover. Then what are the benefits of HSRP? High availability for traffic because you can handle traffic very efficiently, automatic failover mechanism, simplified setup and management, and the load balancing support available. Although the load balancing is not like the GLBP. GLBP load balancing is more than HSRP or VRRP or any protocol. Now, what is GLBP or Gateway Load Balancing Protocol? The Gateway Load Balancing Protocol is a Cisco proprietary protocol again that is designed to enhance network efficiency by providing both load balancing and redundancy. Now, HSRP is not so redundant, but GLBP gives you that load balancing redundancy both. GLBP ensures continuous network service even during router failures. Now, how GLBP works? You have the virtual IP address again. GLBP establishes a unique virtual IP address that is accessible by multiple routers. Now it allows for redundancy and the load balancing in the network environment. So here there is only active concept. There is no standby concept. So that is the difference between the HSRP, VRP and GLBP. Like they are doing the load balancing. So it is all routers are active. No router is in idle mode. Unique virtual MAC address. Each router participating in GLBP is assigned a distinct or unique virtual MAC address. Means enables them to operate without conflicts. Now they are called active virtual forwarders or active virtual forwarders means AVF. And there is one AVG, active virtual gateway. Who is the AVG? The router having the highest IP or highest priority will be elected as the AVG in the group, and it will be responsible for resolving the MAC address like ARP request. Who will resolve? The AVG, but all others are AVF, including the AVG. Traffic distribution. GLBP intelligently distributes outbound traffic across all routers in the group based on their unique virtual MAC address. So your ARP request is coming one by one, and GLBP is load balancing, means it is sharing the traffic or sending the traffic to every node, optimizing resource utilization. Now, seamless failover again. In the event of a router failure, GLBP ensures that the remaining operational routers seamlessly take over the traffic handling responsibility. So, it is the same way like the HSRP works. What are the benefits of GLBP? Load balancing across routers. This is the greatest benefit that wasn't there in previous cases. High availability assurance, optimized network resource definitely, and simplified configuration. So these are about the three protocols VRRP, HSRP, and GLBP that I've told you theoretically. And now VRRP is a bit old one, but HSRP and GLBP we use. So let me take you to the console. So you can see that that is a GNS3, of course, and you just start the routers. So there is ISP cloud and all these routers, router 1 and router 2. I'm taking two routers here. So they are connected. So let me configure the IP address first. The routers are starting. Go to interface of 0 by 0, give no shut, and give IP address, for example, 1001, and you can give any mask. I'm giving default 1. Router 2. Now, if you can say configure the HSRP one, then you can give this standby, then say group number, say 1, and the virtual IP, for example, 100,100, and the standby 1 priority. Priority would be between 0 to 255 and giving anything more than 100 because 100 is the default. So let's say 110. So this router will become the active router. And on the R2, standby number 1 IP 100,000, and the standby 1 priority you need to define? No, because the priority here default is 100. So what will happen? This router has become active router. That you can see the syslog message has come that this router has become indeed the active router, and on R2 again the message should come that this router has become the standby and it has come. And now if I do the failover, so if I shut down this interface, so shut down, then what will happen? It will go to the init state, that is the first state, and this R2 will become the active one. So this is the failover. Like if you have any physical or logical failover, then the role is shifted, and you can check with it, do show standby. You can say that this state is active, and by default preemption is disabled. Preemption means if the active router has a preemption enabled, then it will again become the active once the once the interface state is restored. But I have disabled the preemption. Preemption is disabled by default in HSRP and GLBP as well. So no, definitely the third router, if it has a higher priority, it will become the active router once it is restored. So now this is the HSRP configuration, and you can remove that. standby 1, no standby 1 IP, so 0, 100, and no standby 1 priority 110, and on also R2 no stand 1 0, 100. Okay, now just configure GLBP. So in case of GLBP, again GLBP, then if you give question mark is group number, say 1 or 10, I'm giving the same one, you could give other, and IP, let's say the same 100, you could give other IP as well. Now there is no such priority because in GLBP everything is active. So here if I give GLBP 1 question mark, then you can give the priority, because if I give priority that will be elected as the current AVF. So you can assign priority, but there is no concept of any standby router. So let's give priority say 150, and on the R2 GLBP group number 1 and virtual IP 100, and GLBP group number 1 priority, let's say 100. So this you can configure, and others options are there, forwarder or preempt. You can do that. You can configure the preempt. These options also you could configure. And if you give show GLBP, the GLBP should start, but I think it's the HSRP that is configured. So that is why it is taking some time, because the state is in the init. So it became in the init state. So that is why it is not responding. So what we have to do, you have to go to the interface and you have to give no shut. So now the interface is up, and yes, now you can see the GLBP, the router is now active, and on the other router is in speak state, and it will become active also soon. So every router will become active router. Show GLBP state is active, and you can see the group numbers, both are active, 1001, 1002. There are 2 forwarders you can see. So in GLBP, we have configured the second router as well, and it has become also the active. So you can also check here with do show GLBP. And also you can say that the preemption is disabled, active router 101. Again, you have 2 group numbers, so both router can actually load balance. So this is the forwarder 1 status, this is a virtual MAC address, this one, and this is a forwarder 2 status and virtual MAC address. So everything you can see that indeed in the GLBP it is not active and standby. It is both as active virtual forwarders, AVF, both are AVF. So both are participating in the ARP process. So you can actually load balance traffic across 2 or more routers. So that is a way you can configure the GLBP. So I have shown you the HSRP and GLBP configuration, and that will make you more confident in the networking, because these protocols are absolutely vital for CCNA and CCNP enterprise levels. So these protocols, HSRP, VRRP, and GLBP, are absolutely must for your study for the Cisco certifications. And if you're aspirant for the Cisco certification, CCNA or CCNP enterprise, you should learn these protocols very meticulously. And as a very senior trainer of the Cisco networking courses, I can tell you that CCNA and CCNP is in very high demand nowadays because of the, let's say, the cloud computing, all these things. the networking is first, and you have to set up the network first, the routers you have to configure, and then the cloud servers or even the cybersecurity will come. So definitely everybody should learn the certifications, and I personally take these courses on CCN, CCNP, and I think everybody should learn this course and should enroll it right now so that I can personally teach you these lessons. And definitely it will be very helpful for your careers, I can say. And there is another news for you, a great news that's a contest is running on where you have a questionnaire that is already supplied with this webinar. The link is there given below, and you can click there and you can have a questionnaire there where I have prepared a very easy 10 questions for you. And if you could give, say, 8 out of 10 correct answers, then you'll be eligible for the certificate. Just think about that. That is a certificate that you'll get. So that will be a very helpful tool for your career. So definitely you should go for it right now. And also, we have a flat 10% discount that's running today itself. So if you can enroll in any course today itself, you'll get that discount. So everybody should enroll right now, I think. So I think this HSRP, VRRP, GLBP, this topic is clear to you, and you have got an immense understanding and knowledge from this, and it will help you in your career prospect and also your certification. And also, you'll be able to incorporate these skills in your enterprise networking. So again, I thank you all for attending and joining this webinar once again. I will come with some new topic next time. Till then, keep studying and bye.